Hello, today's topic is the derivative of exponential functions.
Remember Euler's number? E is approximately equal to 2.718. When introducing E, I showed this graph here, which is the graph of y is equal to e to the x. At the time I stated that one important property of this graph is that at 0, 1, it has a derivative of 1. There's another important property of this graph as well. For this graph, at any point, the gradient at that point is the same as the y-coordinate. So at x equals 1, this point here is 1, 2.718, and it has a gradient of 2.718. And at this point here, negative 0.69, a half, the gradient will be a half. So if the gradient is equal to the y value, it's fair to say that dy dx equals y. And since y is equal to e to the x, then dy dx is also equal to e to the x. This function is its own derivative. This is a very special property. Now, we won't go into a proof of this here. You can find one online if you wish, but it's not part of our course. But we are going to use this property and the chain rule that we studied previously to find the derivative of exponential and related functions. For example, what is the derivative of f of x is equal to e to the 3x? Well, let's think about this as the outside function of e to the power of something and the inside function as 3x. Thus, the chain rule tells us it's the derivative of the outside function keeping the inside the same. Since the outside function is e to the power of, the derivative is exactly the same, remember? That has to get multiplied by the derivative of the inside function, so e to the 3x times 3, which we usually write as 3e to the 3x. I'll do one more example. E to the power of x squared plus 4 divided by e to the 2x. We haven't learned how to do division yet, so let's simplify using our index laws. Subtracting the 2x from the power on top, we can turn this into e to the x squared plus 4 minus 2x. Now our derivative is going to be, once again, the outside function is e to the power of, so derivative becomes e to the x squared plus 4 minus 2x, multiplied by the derivative of the inside function, which in this case is 2x minus 2. Now I can rewrite that, and at the same time take out that common factor of 2 from the derivative, and it turns into 2 lots of x minus 1 times e to the power of x squared minus 2x plus 4. That's our final answer.